So what we're going to talk about today is quantitative data. We talked about, I think, qualitative before. So we're still in lesson 4. Or sorry, not 12. The other class is doing statistics in chapter 12, sorry. Chapter 9, lesson 4. And we are actually, this is going to, Simon, you don't get to talk. So this is going to be the last book lesson that we're going to cover. So that means this Friday we should be taking a quiz on all of this, on all of this. So I was going to give you one, but things kind of changed last week, so we ended up not taking that mini quiz. So we'll just kind of shove that into the little quiz we're going to take. So do note that it's going to be like total, like complete, like halt on one idea and go to the other idea, because what we talked about in the beginning with the two-way tables and what was the other thing we did? Oh, the line of best fit and all that. And then we switch and we're talking about mean, median, and mode. Okay, so it is kind of diametrically opposed, yet they're all going to be on the same quiz. So today our focus is, and I'm going to tell you what they call it, the 5-point or 5-number summary. AKA box plot. And today's date is the 6th. A lot of 6s in our date today. Okay, so let's talk about that quantitative data. So in the quantitative data, this is data that can be measured. In other words, you can get numbers out of it. If it's only things like, word answers, then you can't really measure that, and you can't really do these sorts of statistics, mean, median, mode, range, other things like standard deviation, all of those things you can't do unless you can get numbers out of it, okay? All right, so the quantitative data can also get split into 4 equal groups. Can be split into 4 equal groups, and those are called quartiles. What does quartiles sound like? Quarters. And how many quarters do we have in a dollar?
4.
How many quarters do we have in our system here for the year?
4.
We're in the 4th quarter, so we have 4 quarters, okay? So that's what we're talking about. So basically, if I have a set of data, so I'll give you an example. So we have 24, 25, 28, 31, 35, 36, 36, 38, 41, 41, 45, 50, 51, 54. So what I can do is figure out how many numbers I have and find what the median is. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. No, is that right? Did I get them all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 14 numbers. So that means between the 7th and the 8th number. So hold on, let me do it over here. So if I have 14 numbers, between the 7th and the 8th number is going to be my physical median of the data, because the data is in order from least to greatest. So let's count 1, 2, 3, 4, 5, 6, 7. So my median is going to fall right here. keep wanting to write an A, I don't know why. A median, so it would be halfway between 36 and 38. That's an easy one, I don't even need to calculate it. It's 37, okay? So now what you notice is that I've got two groups of 7 numbers, okay? So I can say, I'm going to erase this out of the way. Get rid of all these little dots. And I can call this the lower half of the data. So the median of the lower half has a name. It's called the first quartile. Or Q1. So I've got 7 numbers. Cut that in half. That gives me 3.5, which means I have to go, the number past 3 would be my lower quartile. So that is going to be my quartile 1. So in the old way we used to teach this, it was called the lower quartile. The new way, they just call it Q1. The median overall is called median, but he could also be called quartile 2. Okay? So the same thing happens on the other side, where we have the upper half of the data, and its median of the upper half is called the third quartile, so is the third quartile. Or Q3. So again, I have 7 numbers on that side, so it would be the 4th number over. So 1, 2, 3, and what you notice, there's 3 numbers in front of it, 3 numbers behind it. So that's your third quartile. Jacob, this is your focus. So if you notice, I basically have split all my data into groups of 3. I've got 24 through 28, I've got 35 through 36, I've got 38 through 41, I've got 50 through 54. So that's the 4 equal groups. What they're talking about is how many numbers are in there. They're not talking about the values of the numbers, just the quantity of numbers, okay? Done.
Is Q2 the median?
Yes, so he has, we can give him his name as well. But they rarely call him that, they almost always call him median, okay? Okay, because you can't call Q1 and Q3 medians, even though that's mathematically what they are, because then you're like, well, what median are you talking about? So that's why they came up with alternate names. But we still like to call Q2 median, okay? All right, so basically what I've done without really telling you is talked about what is the 5-number summary. So far I came up with 3 of the numbers. What would be the other 2, do you think? If I'm looking at data and I want to analyze it, I've got what the middle of the data is, the middle of the first half, the middle of the second half. What else do I need to complete what I'm going to draw?
The first one and the last one?
Exactly. So what I need is also the least value and the greatest value. So now I have 5 points. Oh, Lainey is bringing them in here. Okay. So, we'll pause. Back to the matter at hand. All right. So what we just described was the 5-number summary. In the algebra book, they call it the 5-point summary. So let's talk about him. So the 5-point summary,
We have another 15.
no, that's ours. That one can come in.
That's the point.
So the 5-point summary includes the 5 values. Now, I'm going to give you a different name. It's a more mathematical name than least value and greatest value. What do you think would be a more mathematical name? In fact, both the least value and the greatest value have a more mathematical name that starts with the letter M. So the least value,
Mode.
no, mode means the number shows up most. Oh, I heard it.
Most.
Somebody said it over there. Did Kiana say it?
Minimum and max.
Minimum and maximum. Okay, so it includes the minimum, sorry, that shows you how well my hearing's working, which is the least value. Yep. The quartile 1, which is, again, the median of the first half. It includes the median. And as you rightly pointed out, he also could be called Q2, but most people don't. You have the third quartile, which is the median of the second half. And we could call it the last half, either way. And then we have the maximum, which is the greatest value. Okay. So how we use the 5-point summaries, we create a box plot out of it. Now, up until Common Core, they used to call this the box and whisker plot
Oh, yeah.
because it has these 2 strings coming out of it, so they called those the whiskers. But I guess that didn't sound very mathematical, so Common Core said, let's just call it a box plot, okay? So, create a box plot using, oops, these 5 data points. Okay, now I am going to show you a generic one, or we can go back to the one that we did. Let's do the one that we did, had all that data on. So my numbers went from 24 to 54. So that's a pretty big, wow, that's like 30 range. So counting by ones is not going to be good. So I'm going to count by twos. So we'll have 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54. So 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54. So again, range is what I use to determine my intervals that I count by. And again, we don't normally count by threes, because that's awkward, because then we're placing things at thirds. We should count by ones, twos, fours, fives, tens. If our numbers are super large, 50s or 25s, okay? So that's how we figure out what we're going to count by. I usually want to have no more than 15 numbers that I'm putting on my number line is kind of the rule of thumb. So put in our number. So what was the minimum in our set of data? 24. So what I do is above the number line, I mark a dot at 24. Okay, and what was the first quartile at? What was the first quartile? The one we circled on the first half? Quartile 1?
24.
No. That would be the 31 that I circled in blue. So we find 31 halfway between 30 and 32. Okay, what was the median of the data? 37. So we find him. What was the quartile 3?
45.
Which one, I'm sorry?
45.
45. So halfway between 44 and 46. And then the maximum,
54.
was that 54? So what we do to create the box is we go to the 3 medians and they create the box. So I draw 3 vertical lines, 1 through each of the medians. So I'm going to do it in a different color, just make it stand out. And I connect them to make a box. And then we connect the box to the minimum and the maximum. So I'm going to just jot down real quickly. Here's your minimum. Here's your maximum. Just abbreviate to min and max. And then here we have quartile 1. Let's see, what color did I do the median? Red. This is our median. It is here in the middle. And then we had green, I think. And this is quartile 3. So this is the hard part to get, is not all of those sections are the same length. So regardless of what they look like, if they're short, if they're long, they still represent a quartile, a fourth of the data. So percentage-wise, each of these represent 25% of the data. Okay. So my question would be, why would all 4 of those sections not be the same size? Why is, let's say, from quartile 1 to the median shorter than from the median to quartile 3? What causes stretching and compressing to go on in your 5-point summary? What do you think? Because it's not about how many numbers it represents. They all represent the same number. In ours, it was 3 numbers in each one of those sections. Okay. All right, let's look back at the data. So the first section went from 24 to 28. The second section basically went from 31 to 36. The next section went from 37 to 45. And then we went from 45 to 54. So what's different from each of those sections? What statistic did we not do that is going to help us on this? Figure out our answer. That would determine the size, long or short. How about range, folks? The range of the numbers differs, and that's what causes us to have a long whisker or a long part of our box if we have a large range. If our range is short, meaning all the numbers are very close to each other, then we're going to get a shorter section. It still represents the same amount of data. However, the distance between the numbers is what determines the length of those sections. Okay? So that's what you guys are going to work on today. You're going to do box plots. So let's see. So notice what I didn't do. I didn't start at 0. I started at my lowest number, my minimum, is where my dot plot, or my box plot, started, at my minimum. And then it stopped at my maximum. I didn't go beyond it. There's no need to, okay? And notice that some of the numbers that I'm graphing aren't numbers that are written there, it's between numbers. And you don't actually place numbers in your box plot. Okay, your box plot is merely looking at the stretching. What we will talk about, and you will in further classes, is talk about distribution and comparing two different things. And that's where it gets interesting. And then you can come up with conclusions, conjectures, based on the evidence that you have before you. So, all right, do you guys have any questions? You need to do another one, or you guys pretty much remember how to do it? Feel comfortable? Because you guys are my silent class. Okay.